Hey space explorers, dive into the wonders of space. Fascinated by space? You're in the right place. Like, subscribe, and hit the bell to join our cosmic adventures. Don't miss the next launch into the stars. Now buckle up. Let's blast off into the cosmos.
Saturn has always captured our imagination. It floats in the dark expanse of space, a majestic world encircled by a breathtaking system of rings. For centuries we have gazed upon it, a symbol of cosmic beauty and mystery. Galileo first saw its strange shape, but it was Christian Huygens who realized it was surrounded by rings. These rings, made of countless icy particles, have defined Saturn in our minds. But today, on July 4th, 2025, our view of Saturn is changing dramatically. We are learning that this celestial jewel is not as timeless as it appears. It is a dynamic, evolving world, and its most famous feature is slowly disappearing from sight. Scientists have made a startling discovery. Saturn's magnificent rings are fading away. They are vanishing at a rate that has shocked the astronomical community, a pace far quicker than anyone had previously predicted. We once thought these icy structures would last for hundreds of millions of years, a seemingly permanent fixture of our solar system. Now we know they might be gone in a geological blink of an eye. This realization forces us to see Saturn not as a static painting, but as a living, breathing entity, undergoing profound changes right before our very eyes, challenging our most fundamental assumptions about how planetary systems work and evolve over time. The culprit behind this cosmic vanishing act is a phenomenon scientists call ring rain. It is exactly what it sounds like. Tiny particles of ice and dust are being pulled out of the rings by Saturn's powerful magnetic field and immense gravity. They then spiral down into the planet's upper atmosphere, falling like a constant, invisible shower. This rain is eroding the rings from the inside out. We learned about this from NASA's Cassini mission, which bravely dove between the planet and its rings in its final moments. It measured this inbound flow of material, giving us the data to calculate just how fast the rings are being depleted, a celestial hourglass counting down. Why is this happening so quickly? The universe is full of tiny meteoroids and is constantly bathed in solar radiation. These forces can give the tiny ice particles in the rings an electrical charge. Once charged, they become susceptible to the pull of Saturn's magnetic field, which acts like a giant cosmic conveyor belt, guiding them on a one-way trip into the planet itself. This process is a powerful reminder that even the most massive and seemingly eternal structures in the cosmos are subject to the subtle, persistent forces of nature. The rings of Saturn are not forever, and we are privileged to be living in a time when we can witness their magnificent, fleeting beauty before they are gone. At Saturn's North Pole, a truly bizarre weather system rages on. It is a massive storm, a hurricane larger than our entire planet, with a shape that defies easy explanation. It is a perfect hexagon. This six-sided jet stream has puzzled scientists since the Voyager spacecraft first flew by decades ago. Each side of the hexagon is wider than Earth itself. Winds inside this colossal structure whip around at hundreds of miles per hour. It's a geometric marvel of nature, a testament to the strange and wonderful physics that can occur on other worlds. A storm that seems to be carved by a divine compass, rather than chaotic atmospheric forces. What's even more fascinating is that this hexagonal storm is changing. As the seasons shift on Saturn, a process that takes many Earth years, sunlight has returned to the northern pole after a long, dark winter. Observations show the color of the hexagon has shifted, from a bluish hue to a more golden tone. This suggests that the sunlight is causing chemical reactions in the upper atmosphere, creating a haze that alters its appearance. It's a living weather system, responding to the seasons just like storms on Earth, but on a scale that is almost impossible for us to fully comprehend. We are watching a planetary atmosphere transform in real time. This incredible northern storm raises an obvious and tantalizing question for planetary scientists. If there is a hexagon at the North Pole, could there be a similar structure hiding at the South Pole? For years, the South Pole was shrouded in the darkness of its own long winter, hidden from our best telescopes and probes. However, as the seasons continue their slow march, the southern pole is beginning to emerge into the light. Scientists are eagerly waiting to see if a southern twin to the hexagon exists. Discovering another one would suggest these geometric storms are a fundamental feature of gas giants, not just a planetary fluke. The possibility of a southern hexagon is more than just a curiosity. It would provide invaluable clues about the deep, unseen dynamics of Saturn's atmosphere. How do these stable, geometric shapes form and persist for so long? What does it tell us about the way energy flows from the planet's interior to its upper layers? Answering these questions would revolutionize our understanding of atmospheric physics on a grand scale. Saturn is not just a planet with a storm, it is a natural laboratory for studying the forces that shape weather across the cosmos, from the familiar patterns on Earth to the truly alien tempests on giant worlds. For a long time, we pictured the cores of gas giants like Saturn as being simple, a small, solid, rocky ball surrounded by a massive envelope of gas. It was a neat and tidy model, but as is so often the case in science, the universe proved to be far more complex and interesting than our simple ideas. Recent data, gathered by studying the subtle wobbles in Saturn's rings, has completely upended this old picture. The heart of Saturn is not a solid, distinct sphere. Instead, it appears to be a fuzzy or diffuse core, a vast region where heavy elements like rock and ice are mixed with the planet's hydrogen and helium gas. This fuzzy core is enormous, stretching out to nearly 60% of the planet's entire radius. This is far larger and more blended than any of our previous models had ever suggested. It implies that the boundary between the core and the gaseous layers above it is not a sharp line, but a gradual transition zone. This discovery forces us to rethink how planets like Saturn formed in the first place. It suggests a much messier, more chaotic process of planetary creation, where materials didn't separate as cleanly as we once thought. Saturn's very structure tells a story of its own turbulent birth in the early solar system. This unusual core also helps explain another of Saturn's great mysteries, its unique magnetic field. Unlike any other planet in our solar system, Saturn's magnetic field is almost perfectly symmetrical. It aligns almost exactly with the planet's axis of rotation. On Earth, Jupiter, and other planets, the magnetic field is tilted. This tilt is thought to be crucial for driving the dynamo, the internal engine of moving, conductive fluid that generates the magnetic field itself. Saturn's symmetry presented a deep puzzle. How could it sustain a magnetic field without this essential tilt? The fuzzy core provides a potential answer. The layered, mixed nature of the diffuse core could allow for a different kind of dynamo to operate. Perhaps heat-driven convection within these layers, combined with the differential rotation of the planet, is enough to generate the field, even without a significant tilt. This makes Saturn an extraordinary natural laboratory for studying planetary magnetism. It shows us that there's more than one way for a planet to create a magnetic shield, protecting it from the harsh radiation of space. By studying Saturn's strange heart, we learn more about the fundamental processes that govern all planets, including our own precious world. Beyond Saturn itself, one of its moons has seized the spotlight and ignited our hopes of finding life elsewhere. This tiny, icy moon is named Enceladus. When the Cassini spacecraft flew past, it discovered something astounding. Enormous plumes of water vapor erupting from cracks in the moon's icy surface, shooting hundreds of miles into space. These are not just wisps of gas. They are powerful geysers, evidence of a vast liquid water ocean hidden beneath the frozen shell. An ocean on a small moon so far from the sun was a revolutionary discovery, instantly making Enceladus one of the most compelling places to search for extraterrestrial life. The discoveries didn't stop with water. By flying directly through these plumes, Cassini was able to taste the ocean of Enceladus. It found not just water, but also organic molecules, the carbon-based building blocks of life as we know it. More recently, analysis of the data revealed the presence of phosphorus, a critical element for DNA and cell membranes, and one of the last key ingredients for life that we were searching for. With liquid water, a source of energy from tidal heating, and all the essential chemical elements, Enceladus has everything we believe is necessary to support living organisms. The question is no longer could life exist there, but is life there? These tantalizing clues have spurred us to action. Humanity is planning its return to the Saturnian system. NASA is developing exciting new missions to explore these worlds up close. The Dragonfly mission, a car-sized drone, is scheduled to launch and fly through the thick, nitrogen-rich atmosphere of Saturn's largest moon, Titan, exploring its methane rivers and organic sand dunes. Furthermore, scientists are passionately advocating for a mission like the Enceladus Orbolander, which would first orbit the icy moon to analyze its plumes in detail before landing on the surface to search directly for signs of life near one of the fissures. Our journey with Saturn is far from over. In many ways, it is just beginning. Every new discovery, from its fading rings and hexagonal storms to its fuzzy core and life-bearing ocean moons, reveals a system far more dynamic and complex than we ever dreamed. Saturn challenges us, inspires us, and beckons us forward. It reminds us that our solar system is not a static collection of rocks and gas, but a place of constant change and endless wonder. The secrets it holds could redefine our understanding of planetary science, and perhaps our own place in the cosmos. The great ship of imagination is ready to set sail once more for the ringed planet.